Hello folks, today I'm going to show you a little bit of how Google Refine, or as it's now called OpenRefine, operates and how it can be used by digital public historians for doing some data cleaning work. Today we're actually working with data from the George Santayana documentary editing project, their online database. I've been trying to clean that up. They've had some problems transferring between database system with misplaced data and poorly transferred data. So this is the screen that you will typically see when you open up OpenRefine. Since I already have files loaded in here, it opens up with Open Project. You'll notice that there are several different versions of files that are in the system. It can be a bit quirky to figure out just which file format will work best for what you're wanting to do. In my case, with bibliographic data, the XML files tend to operate a little smoother and they break the records a little more appropriately. Given the nature of bibliographic data, we really want to be cautious about using tab separated values or comma separated values as our file format, because those are naturally occurring items within the cells that we're using. So we'll go ahead and go into the file, wait for it to load. There is some load time associated with any action in OpenRefine. That is a bit of a drawback, but its power is in making large batch changes as opposed to editing individual cells. If we were editing individual cells, it's probably more appropriate to do that in a spreadsheet software such as Microsoft Excel. A little bit of guidance about what we have going on here. If you look, we have our file name that's available. Down here on the left side, we have it's labeled facet filter. When we run our search parameters to be able to pull up data and to edit data, it will pop up in the sidebar. They do offer a numerous amount of screencasts and tutorials to figure out how to work with the system. The Programming Historian has one of the best ones that I've seen, which is very, very helpful because OpenRefine actually has its own language for how you manipulate cells in bulk, and they call those recipes as opposed to codes or algorithms. You'll see right next to that facet filter we have an undo redo. This is a amazing feature that makes Google Refine and OpenRefine a lot more suitable for making bulk changes to your data, because you can walk away from the program, come back to it, and you can walk backwards from any change that you've actually made in the system so far. And that's very, very helpful if I find that I've got a weird formatted cell where 2 or 3 cells are together. I can walk back all the way to when the very first time that I opened this project and take away any step along the way. Also, until you make changes, it records what you've done until you backtrack. The easiest way to think of this is it's a permanent version of the Adobe Control-Z function and the history function in Adobe. Very, very handy for anybody who's working with data on a regular basis. We're going to flip back to the facet filter function. Come over here. Our header tells us how many records we have. This does update as you make changes to records. You can combine records and do things of that nature. You'll see immediately below that it says you can show as rows or records. I prefer to work in records rather than rows. Rows are a way of actually manipulating the data within cells a little better. For example, if you have multiple pieces of information in a single cell, you can flip over into rows, break those cells apart, edit them, and then recombine them by flipping back to records once you're done. it's a bit tricky for what I'm doing, and it has a tendency to be very data loss heavy when I do it that way. So I tend to work just with the records themselves. You do have the option to alter the number of records shown at any given time. Generally, I just leave it with 10. That's the basic setting. It may look like I don't have any data here, but I have a lot of data in this system, and it runs very, very slowly if I try to view all of them at once. Not to mention, with bibliographic data in particular, it doesn't do me a whole lot of good to be able to physically view them, as opposed to just looking at the batch collections of what's in those data sets. Sliding over here to the next side, you can alternate between different sections of data. Right now it's just by default showing records 1 through 10. If I know that I'm looking for a particular cell, I can change that. It doesn't really do me much good, again, with this particular project that I'm working on. Up above, you'll see that we have the ability to open other files. We can export into a number of different options. There are tab-separated and comma-separated values to make things a little easier on you if you're used to working with those. With this project, as I said before, we have tabs and commas as a part of the actual cell entries, so it doesn't work very well. Exporting into Excel directly tends to keep our data a little bit safer as I go. If you're interested in those other functionalities, there are plenty of tutorials on the web that'll tell you how to use them appropriately. There is help functionality. It is limited, as this was a project that Google started and then scuttled and was picked up and run with by other scholars. That's why it has two names, Google and OpenRefine. Coming down into our records that we have, we can click. This little file menu that we have here gives us access to most of the tools that we're actually going to use for manipulating data. Faceting is a way of pulling out and collating together the entries within cells. Another way to think of this is how you have the filter function in Excel, except for the fact that we can edit those from this faceting. We can run a filter. We can edit cells in bulk all the way down. One of the most useful functions with this, I can transform blank cells into cells that say bad data or have some other identifier that enables me to be able to see what is wrong or what is missing in our data set that we have. Also useful in operating as rows. Once you're viewing as rows, you can split apart multi-valued cells. For example, if I have 2 or 3 authors, I can break apart that one cell into a cell for each one, and then I can standardize those spellings across all of my records. It's very important for us to be able to have our search functionality operate properly, because our system does not support wildcards. Once you're done working with those, you can then recombine those cells together. From the edit column function, you can break apart columns into separate columns. You can combine columns with a little bit extra work, and you can add columns. You can also rename and delete columns from this tool, as well as moving around where those columns are placed in records. The transpose function I haven't used a whole lot of. I'm sure if you're interested in knowing how to do that, there is a tutorial somewhere online for it. The view function is rather handy if you're working with lots of columns as I am. You can collapse columns so that you can actually see the records you want to work with rather than having to scroll. Reconciling I haven't done a lot of either. It's a system that I just haven't encountered or learned how to use yet. So we're going to go back up to facet, and we're going to run a text facet on our data and see what we pull back. These are authors and contributors to the different documents and texts that are a part of the database. So this is the way that most of it appears. It's very easy to see. You can actually facet by, in my case, I'm faceting by name because that's the most important part to me. You can also facet by count, which arranges things based on the number of entries that have that particular tag. As you can see right now, I have a little over 2,000 different names in our database. That's quite a bit of alternatives and possibilities for errors to be in that data. And we've encountered that over having 10 or 15 different individuals input records into this system. We have lots of different spellings of names, we have lots of truncated names, and we have lots of misspellings of names. So my hope is to actually fix those particular issues. There are two ways to do this standardization. The first and the more popular is using this cluster functionality. As you can see, we pull it up. It makes educated suggestions based on an algorithm for things that look very similar to one another. We just kind of scroll through and we can pick what's correct and what's not correct. All right. One thing, and this will go to the way that you arrange your data and kind of your standards that you keep as an organization. In my case, people are more likely to truncate names or abbreviate names, and that doesn't do much good if someone's searching for an individual. So I'm going through, and if I have the information about what a full name is, adding it in. So we merge, we rerun that test, and we don't have anything new that really came back that we can feel confident in altering. This keying function is just simply a different algorithmic test that we can run against the data, and we can see that it actually pulls back different information. There are 4 of them that rely on a key collision method. I'm sure that there are people out there that can explain how those algorithms work. For most historians, it's just practical to run each of those tests in sequence and see what you get back and what you can fix. You do have to be conscientious of what's in your system. For example, we have an entry that's labeled Locke John and Luca John. I can't be certain that those 2 individuals are not the same person, or that they are, so I'm not going to cluster those together. On the other hand, McCormick John O and McCormick John most likely are the same person, so I can combine those records. The same here with Ferre Lewis. And you just need to use your scholarly discretion for what and how you're going to make these combinations. Be careful when you're doing it, because once you've made it, backtracking is a bit of a nightmare. You can do it, but you basically lose all the clustering that you've done in any given session, and you have to start over. One thing to look at right here, we have Blackmer Richard P. and Blackmer Richard Palmer. You're going to see in our next test that we run, it's going to pull back yet another record, and I'll show you how to edit that as a manual edit. All right. There are another 3 tests that we can run against this data to pull those back, and you can manipulate that in several different ways. For the time being, though, let's go back and I'll show you how to do a manual edit. And this is important once you run all of your clustering. Those cluster functions are very good at finding patterns. They do miss things that you can catch only by actually scrolling through and reviewing the data record by record. For example, scroll down. This is one that I discovered earlier and left just for us to be able to correct here in our little tutorial that we have right now. We're almost there. Here's one. Bentley Eric. We can hit that. We'll make it match the other record. If you notice right now we have Bentley Eric 1 and Bentley Eric R1. Most likely they're the same person, so we edit to make sure they match one another. And now we have one entry that corresponds to two different records, and they're all pretty, and they play nice with one another when we run our searches in our system. This here, where it says Blackmer RP and Blackmer Richard P, they're the same person, but our search functionality does not pull back both of those records when we run a search. We need to make them match to achieve that objective. Alright, so now that we've done that, we'll wait for it to load. And if you've noticed, there's a lot of pauses and the system says that it's working. That is one of the drawbacks to working with OpenRefine. If you're wanting to do things very, very quickly, this probably isn't the system for you unless you can't do it any other way. Now that we've made those changes, we're going to continue doing that through all of these different columns that we have. And I have quite a few, until I feel confident that I'm mostly done with what I'm working on. After that, I'm going to export it into Excel, where I can transfer it from being a computer readable set of columns and row labeling. For example, here we can see that our name titles for our different columns are a little clunky. That's because XML generated those column headers. To be able to alter that more efficiently, once I go into Excel, I'll update that to say author or authors. And then edit that document again to turn it into a hard copy of what will go into that database system. It's important that you do use discretion in what you're actually doing in OpenRefine. It works well for this sort of bibliographic information. There is a programming historian tutorial on how to use it for editing metadata related to archival collections. But it's something that's not very well suited just for regular spreadsheet editing, just because it's too much tool for that particular job. If you're interested in learning how to use all of the different functionality that's a part of OpenRefine, look around online. There's lots of good information and tutorials, but I hope that this provided at least a decent introduction to how to actually operate the system and what it's useful for. Thank you.